Good evening. I'm Steve Crouch. I want to welcome you to the public lecture for the College of Science and Engineering. This is one of a series of events that we hold each year to promote science and engineering to the general public. Our speaker tonight is Joe Palca, who is the science correspondent for National Public Radio. Mr. Palca has worked as a journalist for over 30 years, including time as the Washington News editor for Nature and as the senior correspondent for Science magazine. He joined the National Public Radio in 1992 and has covered science topics ranging from biomedical research to astronomy. His current focus at the NPR series is Joe's Big Idea, which explores minds and motivations of scientists and engineers. He's received numerous awards for his work and is co-author of the book, Annoying: The Science of What Bugs Us. I've got to read that. The title of his talk tonight is No News is Big News: Adventures in Science Journalism. Please join me in welcoming Joe Palca.
I think I'm going to do this seated because most people are used to not seeing me when I speak. So I'll just sit here and talk, and you guys can close your eyes and pretend you're No, I won't do that. I actually wanted to do a talk once where I came in from the outside, and just did the whole talk from outside the room. See if that would. Well, thank you. Boy, it's nice to be here. Thank you all for coming. So I'm going to share with you a little bit about what I do and how I do it, and how weird it is to be a science journalist. I guess Leanne Hansen used to say, "Oh, so that's what you all look like," which I thought was kind of funny. I've been at NPR since 1992, as you heard. It's 23 years in the same dead-end job. But I have had a lot of fun doing it. And just to give you, I thought I'd give you a moment or two of my background so you'll understand maybe a little bit about where I'm coming from. So I was a graduate student in physiological psychology at the University of California, Santa Cruz. I was studying human sleep physiology, sleep at altered ambient temperatures. I actually also contributed a paper to Vision Research, if anybody ever reads that rag. And I wasn't sure that I wanted to go on in a career in research, and I was lucky enough to get a fellowship from the AAAS, the American Association for the Advancement of Science, that showed me it was designed to take scientists who were on their way to careers in science and say, hey, have you ever thought about journalism? Partly to see if you could get scientists into journalism, and partly so that scientists who went back would understand the kinds of pressures and demands that are placed on journalists and could explain to their colleagues why journalists were such jerks. And as a grad, the biggest change is that, when you're a graduate student and you want to learn about DNA, and this is going to date me, but you go to the library and you read up on it. And when you're a journalist and you want to learn about DNA, you call Jim Watson. And you say, hey, Jim, tell me what's going on here. And it's amazing the chutzpah that journalists have, and they don't even think twice about it. And, it takes a long time as a graduate student, well, it took me a long time, to get out of that mold where I was allowed to just, call anybody, ask any question, do anything, because, journalists are convinced that they're the most important people in the world. And they are. I mean, that's... But one of the things I was saying earlier was that I don't come to journalism with, I didn't go to journalism school. I didn't work my way up from a copy boy to the front page. And I've been mostly in science. I spent 3 years in the wilds of television, local news, and I didn't care for it very much because it's really, it's important and it serves a local function. But in terms of the things I was interested in, it didn't really take on tough science topics and report on them. So I really think of my career as starting in 1986 when I started to work at Nature. But I work in a news organization, and I left Science and Nature, so those were one end of this. If television is one end of the spectrum of journalism, science and nature has got to be on the other end of the spectrum in terms of silly and serious, right? And so NPR is somewhere in the middle, but it still is a public organization. And my argument, and we can discuss this later if you want, but my argument is that science, for the most part, doesn't fit very comfortably into the news format. Because news is something that it's important that you know about it today. It's going to affect your lives soon. It's got to be timely. And most of science, while it's important in the long term, it's not always clear what's the most important on a given day. And you can't go in and say in the newsroom, hey, I've got this story and I don't know whether it's important or not. You have to go in and say, hey, there's this really cool finding. And so you wind up overselling things. So I thought what I'd do is tell you a little bit about the two stories that had the biggest impact of any stories I've done in my career. And the thing that amuses me about both of them is neither had a shred of news in them. And as I said to somebody, it was such a huge story that Nina Totenberg came up to me and congratulated me afterwards, which is like, she never said anything to me before that. And so I'm going to tell you the story, and it actually begins with this gentleman here. I don't know if anybody remembers him, but that guy is, as it says, Richard Seed. He's sort of an intimidating-looking guy. And I heard about Richard Seed in the following way. So a reporter for Minnesota Public Radio, or a producer, was at a conference in Chicago that was organized by Laurie Andrews in 1997 or 98, I don't remember which. And the conference was about assisted reproductive technologies. And the reason that it was being held was that Dolly the sheep had just been cloned. And the question on everybody's mind was, well, if you could clone a sheep, could you clone a human being? And for bioethicists, this was a field day, because it raised all sorts of interesting questions, and bioethicists love to spin out questions that don't have answers, and that's fine. And this was a conference that was trying to point out that the field of assisted reproduction had now so many people that were potentially involved in parenthood. There's the biological egg donor, there's the sperm donor, there's the surrogate mother, there's the actual biological parents, there's the adoptive parents. There's so many people involved, and now there was another one. This was the somatic cell donor who was going to give a cell from and you all remember what cloning is? It's this idea that you could take an adult cell, which they did with Dolly, an adult cell, and put it into an egg that you'd taken the nucleus out of, and then the DNA from that adult cell would then have the genetic instructions that would create this new organism, which would be essentially, not completely, but essentially a genetic copy of the adult from which the DNA was taken. So cloning was a big deal. And this guy was at this conference in Chicago where they were talking about this, and Richard Seed stood up and said in the Q&A, I'm going to start a human clone clinic, and I'm going to clone human beings. And I have to tell you that you guys probably are more familiar with, there's usually conferences on cosmology. And there's almost always somebody who comes in with a bag full of aluminum cans and a tin foil thing on his head because he's worried. And he knows a theory of the universe that he's been told about. And everybody looks and he says, and I figured this all out. And everybody looks at him like, ugh, get us out of here. And that's what this crowd did when Richard Seed stood up and said, I'm going to clone. They all went, And so when my editor, this reporter for Minnesota Public Radio called my editor, he wasn't going to follow the story, but he said to my editor, I heard this and it's pretty amazing, but maybe you want to check it out. My editor came to me and said, Joe, this guy stood up at a conference and he wants to clone human beings. And I said, Anne, have you ever been to one of those cosmology conferences where somebody comes in with a big bag of... And she said, I don't care. I want you to call them and find out if there's something to this. So I said, okay, I'll do it. Because, that's how I know I'm a good journalist. I do what my editor tells me. And so I called him, and he sounded First I did a little research, and it turns out that he's a PhD in physics from Harvard, which doesn't qualify you to be a cloning expert, but he had gotten interested in human reproduction and had actually published a paper in JAMA that was a technique for synchronizing women's cycles to make them more likely to be able to conceive in an artificial way. Anyway, the point is, it was an interesting plan. It worked in a small way. It never got picked up. But he had gotten interested in this whole world of reproductive science, and he said that he was going to do this. And I said, well, you know, what's on about this? And he said, I have a clinic here in Chicago that's agreed to do the steps for me. And that's when I got interested, because there was nothing magical about what the Scottish scientists did in terms of cloning Dolly. The techniques were fairly straightforward. You suck out the DNA from an egg, and you squirt in the DNA, or the whole cell in some cases, from the somatic cell, and that's it. And then you have culture medium, and you grow it. So an IVF lab, assisted fertility lab, could do this. And if he had a lab that was willing to do it, suddenly it went from a kind of a crazy guy with a crazy idea to somebody who, yeah. And the point was, and this, so I went to Chicago, where he was living, and I interviewed him, and we had lunch together. And I remember we had lunch across the street from the clinic where I was going to meet the doctor, because I said that's the sine qua non. If I don't get to meet the doctor, we don't do the story. And he said, no. I said, after lunch, we'll go over there. And we go over there, and he says, it's Richard Seed here to see Dr. So-and-so. I had to agree not to say the name of the doctor, but that was okay. I was cool with that. I understood that it was Seed who was trying to do this. And the receptionist said, I'm sorry, he's too busy to see you. And I don't know if you've ever seen a man deflate, but this man just deflated before my eyes. And then he said, no, he's got to talk. This is an opportunity we have. And so he disappears into the back of the clinic, and a few minutes later, the doctor comes out. And I know it's the doctor because I see his picture on the wall, and it wasn't an actor he hired and brought in. So, but it was the guy, and we sat down and we talked, and he said, yes, I might not be able to do it here in Chicago, but I have affiliates in the Caribbean that I sometimes work with, or some other country, and yes, maybe we could do this. So Joe Palca comes back to NPR and writes a story about Richard Seed's plans. And I'm going to play you a couple of clips from the story which will give you the gist of it. But you'll also hear, when you hear this, let's see if I can find the mouse, you'll hear why maybe Richard Seed doesn't strike you as the person to put, all your eggs in that basket.
This is Morning Edition. I'm Bob Bedworth. A scientist and entrepreneur in Chicago is planning to open what he calls the Human Clone Clinic. The clinic would offer infertile couples the option of cloning themselves if there were no accepted medical treatments that could help them have a baby. NPR's Joe Palca reports on the ethical, legal, and social hurdles that must be cleared if the clinic is to become a reality.
The Human Clone Clinic is the brainchild of Richard Seed. Seed is a Harvard-educated physicist who in the last 2 decades has become interested in human biology. In the early 80s, he developed a new fertility technique that produced a healthy baby, but the technique never became a standard medical treatment. But Seed retained his interest in embryology, and when Scottish scientists announced they had cloned an adult sheep, Seed saw the opportunity to use the same technology for humans. To try the Scottish cloning technique, Seed says you would use micromanipulators to remove the DNA from a woman's egg and then replace it with the DNA from the person you want to clone.
The really important part is then you culture this egg, which is presumably fertilized now, for about 5 days, and you want to grow it up into a 50 or 100 cell stage, and you can actually see that the fertilization has taken place and see that you have a normally developing egg.
Seed says you would then transfer this embryo to a woman, and approximately 9 months later, if the technique works, you get a baby. But the key word here is if. It took the Scottish scientists more than 270 tries to get a single successful clone, and there are no other published reports of a cloned adult animal, so the technology is far from perfected in animals.
Okay, so the piece goes on from there, and it talks about why it's difficult and what the ethical considerations are, and I found an embryologist who was talking about why it would be difficult in humans, even possibly more so than in sheep. And then I talked to an ethicist who said, look, when IVF was first proposed, it was also playing God, and we shouldn't be doing it, and it's wrong, wrong, wrong. And then we finally accepted it as a new technology. So he was sort of saying, it could be acceptable someday. And then the piece finishes with this. And this is where you get a real sense of Richard Seed.
Practical considerations may prevent Seed from opening his human clone clinic. Right now, he doesn't have the money, he doesn't have a firm commitment from the physicians who must perform the procedure, and he doesn't have an infertile couple willing to undergo the procedure. But Seed says he has faced similar roadblocks in the past with other projects, and he believes he can overcome these. In fact, Seed believes there is a moral imperative to proceed with cloning.
God made man in his own image. God intended for man to become one with God. We are going to become one with God. We are going to have almost as much knowledge and almost as much power as God. Cloning and the reprogramming of DNA is the first serious step in becoming one with God.
Seed says someone will eventually be the first to try human cloning. Seed hopes it will be he. Joe Palca,
Okay.
NPR News, Washington.
So anybody who can listen to that and think there might be something just a little off about this guy. But now you heard the story, right? He doesn't have the money. He doesn't have commitment. He doesn't have the time. So there's no news whatsoever. Nothing. If I could use the expression all hell broke loose, I would be accurate. This story went rocketing through the roof, not because Joe Palca did this interesting story about, the issues related to human cloning. It was Joe Palca says that Richard Seed is going to clone a human being. And suddenly, every news organization in the world wanted to talk to Richard Seed. And since I was the only one that had his phone number, they all wanted to talk to me. And what was really pleasant was that the New York Times tried for about a week to ignore the story, but it wouldn't go away. And so eventually they had to do a story about it, taking a snooty attitude, which of course is what they do. But the point is, they were right. This was, and I got a lot of criticism from my colleagues for saying, well, why did you talk about him? I mean, he's obviously not that credible. Right? And my argument and my editor's argument, and I'm still proud of this piece, is at the time, there was nobody to stop him. I mean, the FDA came out with a bunch of, we would have to regulate, blah, 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 but there was not anything clear that was written down, that was in statute. And believe me, Congress noticed this right away, and there was all kinds of laws proposed and hearings held and all kinds of stuff. And I'm not saying that I made all that happen, but it certainly jacked up the interest. And so why did this become news? Because it was the timing. It was very much in the news that people wanted to try cloning, or could humans be cloned? I mean, this was the big topic after Dolly was announced. And so it just reminded me, and I bring it up to remind you, that things become news. I mean, he obviously, now nobody's heard of Richard Seed because he didn't succeed. And he passed away a couple years ago. And it was very strange because I got a call from his daughter who asked me if I would give her a copy of this tape. because she remembered hearing her father on NPR and wanted to save that memory. So I did. Anyway, that's one example of my biggest story. This is the second example, and it's much more recent. So this is in 2012, and I'm going to give you this is another this is another example of no news. So I have really, really, really enjoyed in my career covering the Mars landings. And Mars landings come as close as anything to truly newsworthy science engineering stories because, you know, unlike most other things, the thing's going to land at 8:07, 21, 30 seconds, and it's going to land then, you know. So you have a countdown, and you know it's going to happen, or it's going to crash, one or the other. And so it's lots of fun. There's lots of tension. It's got built-in drama. It's very exciting, and I love going to JPL and watching, and it's wonderful. But I also feel that there's a lot to be covered going forward. And what happens is, you know, the media all streams out to the Jet Propulsion Lab for the landing, and then they get bored, and they go home, and the science never gets any attention. And I kind of feel I pride myself in saying, look, I'm going to keep coming back, and I'm going to keep talking about it, because I think, you know, we're not just doing this as a parlor trick. We're trying to learn something about Mars. Okay, there's other people who think anything about Mars is a parlor trick, but never mind. Anyway, so it was a year or so after, no, it wasn't a year even. It was 5 or 6 months after the landing. And I was on my way out to California for another reason, and I had a day free, and I said, I'll just go out and say hello to my friends at the Jet Propulsion Laboratory and find out what's going on with the rover. And so I got a call like the day before I left Washington, and this guy said to me, Joe, you didn't hear this from me, but the Mars scientists are over the moon because they think that they have seen signs of carbon in their very first soil sample that they've processed from the Mars soil. And they are ecstatic. They never thought they would see it this soon. They were, you know, but they're just completely. Now, why is that important? Well, you know, the carbon is the building blocks of life. And yes, it has to be a reduced form of carbon, and it's not so interesting to find carbon dioxide because we know that's there. But anyway, the complex carbon molecules would be very exciting. Methane, even, you know, anything that was a somewhat reduced form of carbon, it would be totally exciting. And so this guy said to me, you should ask him about that, but you can't say you know this. You can't, and you didn't hear it from me, and you can't say anything. So, okay, so fine. So I go to JPL, and I go and interview. First, I interview the chief engineer on the project, who's a guy I've known for a long time. I say, hey, Rich, how's it going? Great. How's the rover? Fine. Learning anything interesting? No. I said, after we talked for 20 minutes, I said, Rich, that was the most boring interview I've ever done in my life. Everything was fine. There was nothing to report. So then I go to John Grotzinger's office. And John Grotzinger is a geologist at Caltech who was then the principal investigator on the rover. And, you know, he's a good guy. And I'd interviewed him before. Not that he remembered, a little crestfallen about it, but that's okay. And I said, how's it going, John? Great. We're getting really, you know, things are fine. Everything. Anything particularly interesting? No. We're just, you know, a lot of cool stuff. So at one point, and I'm going to tell you the backstory because you won't hear it. I'm going to play another clip. But so at one point, we're doing this interview, another one of these totally boring interviews, and my tape recorder battery dies. I say, can we stop for a second? I got to change batteries. And when we stop, he jumps up and goes to his computer screen. So I put the batteries back into the recorder, the new batteries, and I say, what are you looking at? And he says, well, you'll hear what he says. But it was that moment when he sort of broke down a little bit. And that's what I'm going to play for you about. It was a little less boring for a few seconds.
The lead scientist for the Mars rover mission is John Grotzinger. I interviewed him in his office at the Jet Propulsion Laboratory in Pasadena last week. While I was setting up my equipment, Grotzinger was glued to his computer screen.
We're getting data from Sam as we sit here and speak.
Sam is a kind of mini chemistry lab.
And the data looks really interesting. The science team is busily chewing away on it.
Put a sample of Martian soil or rock or even air inside Sam, and it will tell you what the sample's made of. Right now, Sam is working on a Mars soil sample, and Grotzinger says the results are earth-shaking.
This data is going to be one for the history books. It's looking really good.
Grotzinger can see the pained look on my face as I wait, hoping he'll tell me what the heck he's found.
I know I'm killing you.
So there we leave it. Big news from Mars. So I call my editor and I say, I know what he's talking about. And she says, you got to get somebody to confirm it, because he didn't say anything. So I call all sorts of people. I mean, I call a lot of people. And one thing NASA's good about is keeping their yap shut, or NASA people, because everybody knows that if they get out of line, they won't get another penny from NASA. And that would be bad for most Mars scientists, because most Mars scientists like to get money from NASA. And so everybody I talked to said, well, I've heard rumors, but I really can't say, or stuff like that, words to that effect. And so we're sitting there, and I'm getting nowhere and getting really frustrated that I've got this great tape, and I know what it is, but I don't know what it is officially. And my editor and I suddenly say, hey, you're doing this project called Joe's Big Idea, and you're supposed to explore the minds and motivations of scientists and inventors. So why don't we do a piece that talks about the nature of science and what happens when you have an interesting finding and you want to run out and tell everybody about it, but you know that it's preliminary, and so, you have to hesitate. So Joe Palca, knowing what the deal was, called Dick Zare. Oh, I remember I had trouble with this the last time. And Dick Zare, okay. Dick Zare, who I'm sure some of you know, was involved in the polyaromatic hydrocarbon story in the Allen Hills Mars meteorite. Does anybody remember? Anyway, there was a meteorite found in Antarctica that was from Mars, and there was this paper came out in Science that was released by the White House. That's how big a deal it was. And it said that there were these carbon molecules, and maybe this was life. So Zare I went to because I knew that he would tell me an interesting story about what it's like to have something. Oh, man, I tried this the last time. Okay. Right, so what I'm going to do is I'm going to just cheat and go over here.
He did break down and tell his family.
I remember around the dinner table with great excitement.
So he wasn't allowed to tell anybody because of the embargo on the paper.
And my daughter Bethany, what it was we were doing.
And then he experienced something many parents can relate to when talking to their kids.
Bethany looked at me and said, "Pass the ketchup." So not everybody was as excited as I was.
Zare says, in a way, scientists are like artists. Sharing what they do is a big part of why they get out of bed in the morning.
How many composers would compose music if they were told that no one else could listen to their compositions? How many painters would make a painting if they were told no one else could see them?
Zare says it's the same for scientists.
The great joy of science is to be able to share it. And so you want to say, look at this, isn't this interesting? Isn't that cool?
For now, though, we'll have to wait to see what's got Mars rover scientists itching to say what they found. Joe Palca, NPR News.
Okay, so once again, Joe has come forward with a story totally responsible that said they found something, they don't want to talk about it yet, and it's understandable. There are reasons science don't want to. I said, you want to check it, you want to be certain. In fact, I went on to say that they had found a signal of methane, which they subsequently decided was from atmosphere that they brought with them from Earth, and they didn't want to make that mistake again. So fine, so no problem. Well, good luck, Joe, because the next day, again, everybody, NASA has a secret, and they won't tell us. That's not what the story I did, but that's what happened. 500,000 web hits. And I picked a few of them out because I don't understand a single word except for and then this one, another language I don't understand. And then this I also like. So I felt famous in a way. But again, that's sort of the issue that makes awkward company sometimes with science and the news. So I thought I'd tell you a couple more didactic points, and then since, well, maybe people have questions because I like to answer questions, but I wanted to make the point with this slide that the trouble with being a science correspondent is that you usually don't know until a few years later what was important in a given year. So you have to understand that every week I get the table of contents of Nature and Science and PNAS and any other journal that I care to get the table of contents for, JAMA, New England Journal. And so I get to see before anybody else, at least in the public, what's going to be in the journal. And the trick is that these are under embargo. And if you know what that means, it means we're showing you this in advance. You can't talk about it in public or on the radio or anything like that until the embargo lifts. And that's the deal, because we think if you have a little bit of extra time, you'll do a more responsible story. That's their story about it. My story for them is they just want everybody to pay attention and get more coverage on that day, so that you notice all the stories come out on Wednesday if it's Nature and Thursday if it's Science or whatever. Anyway, so it's self-serving, but it's also valuable. So Nobel Prize in Physics 2010, you would think. No, one of the things that the Nobel Prize Committee does now is they provide these really, 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 really helpful press releases so that journalists like me who have to go on the air and 45 minutes after the Nobel Prize is announced are given information about what the Nobel Prize is about, because maybe people knew about graphene. I guess some people did. But they had a very nice description of what it is, and it also had this reference in it. That's the paper that they published in Science where they first described this substance, graphene, anatomically thin carbon films. Now, as I said, I had that copy of Science in 2006, and so did every other smarty-pants science journalist in America. And so I went to see how many of us covered the story. And the answer is this. Now, I was hoping it would be none because it would be a better story, but I'm going to tell you why New Scientist covered it, in part because it came out of a British university, and the University of Manchester in England put out a press release. Electronics Weekly, Extreme Tech, Investors Business Daily, Space Daily, I salute them. They recognize this is important. Manchester Evening News, that's Manchester, England. It was a local story for them. United Press International, I don't know what was going on with them. They got lucky. Anyway. My point is, it was missed. You don't see the New York Times or Time Magazine or NPR or any other station up there, big name up there, because we don't know. And I've got other examples of this, but my point is, I can't go down to the newsroom and say, ask me in 6 years what's the most important science story in 2006, because they want to know in 2006. And so what that does is it puts pressure on you to find stories and to cover stories that may turn out not to be all that important, and this is just to say, we all get it once it wins the Nobel Prize. It's not so hard at that point. So what happens is this. You get a lot of coverage for a paper like this. This is a paper that was in Science. I'm sure some of you are familiar with this. A bacterium that can grow by using arsenic instead of phosphorus. Well, that was a big deal because, there were no other organisms that could grow that don't need phosphorus. And this was found in Mono Lake in California, and everybody got excited, and there were hundreds and hundreds and hundreds of news stories about it. And everybody who knew a little bit better thought, that's crazy. And then a year later, Science published this paper. So we are under pressure to find important, exciting stories, and I think what happens is we sometimes succumb to talking about things that probably aren't quite ready for prime time. And sometimes we're given a little boost by the public affairs offices at universities who are telling you, or companies, or universities or companies that hire public affairs officers. Okay, so why does science become news? Well, I gave you those examples. I mean, I picked things that were were timely. You know, I was doing something about Mars. I was doing something about Richard Seed. This is a funny graph, and I apologize, but I'll read to you. On the left-hand axis, the y-axis, it's the number of citations, and on the bottom, it's per month starting in July of 2011 and going to May in 2013. And let's see, does anybody know? I should bet. Does anybody want to make a bet that they can tell me what this is? Guess. So this is a news story or a phrase that was in the news during this period of time. Anybody have a guess? Think about I don't blame you. I had no idea. But it's kind of funny. So here's what it was. I simply did a search for the phrase BRCA in the media. Now, BRCA, the breast cancer susceptibility gene, why is there this peak in May of 2013? I guess the story's getting a little old by now. Right. And actually, somebody pointed out that in April of 2013, there was the Supreme Court oral arguments in the case about the patent that the company was trying to protect. Anyway, so one other thing that I thought was interesting that somebody pointed out to me is you see in October of 2011 and then October of 2012, there's a little bump. You know what that is? Breast Cancer Awareness Month. So it does something. But my point is, it becomes news for no intrinsic scientific reason. You get swept up. And I don't mind that. I mean, I get that. I'm a news person. But it bugs me, or it doesn't bug me. It just makes me wonder, you know, what we're doing when we talk about science in the news. Are we just playing along with this sweep of stuff? Or are we doing something important? And then I have to say, this graph made me laugh because it reminded me of this graph. I haven't been able to think of what the correlation would be. But it looked so familiar. So anyway, where does that leave us? Well, it leaves us nowhere really, except for this idea that I had, and now I've been given the luxury to pursue it, which is I've been telling people I'm sort of done. I don't want to pretend anymore that the science is a bunch of breakthroughs. I think people should understand that it's a process of understanding the natural world, and it's a way of asking questions. And engineering's a little different. I'm becoming more fond of engineers because they have a bottom line. They want to, you land on Mars, it either works or it doesn't work, right? It's not like I'm going to write a paper about and get all the credit for the crashing because I think I know why. Whereas scientists will try and figure out that dodge. But anyway, I've just decided that I don't want to oversell anything anymore. And so what I've started to do is to look for stories that are interesting to me, and I assume by extension interesting to others, and then to tell them in a way that I think is interesting and captivating, and not to pretend that they're anything more than they are, but to talk about science as a process. And so I'm happy to say that a very nice foundation called the Lemelson Foundation got wind of this thing that I wanted to do, and they said, we're in. And so they gave NPR some money, and that's allowed me to do this. And in a way, I feel a little conflicted because in the olden days, again, as a news person, I didn't have any idea where the money was coming from. It was a mystery to me. Now we're in a slightly different environment, and it's okay for me to know that they're my benefactor. So I guess I feel I'm grateful to them for letting me play in this sandbox. But the truth is, I think that what has to happen, I actually really like science. I hope people are aware of that. I like talking about it, but I don't like the way it's oversold, sometimes by scientists themselves. The example I was thinking is, the California Institute of Regenerative Medicine. There was a proposal for California to spend $3 billion over 10 years on stem cell research in California. And it said in the charter, we will have cures in 10 years. And I didn't hear a single scientist stand up and say, we can't take money under those circumstances because it's not honest. They said, yeah, give us the money. And I don't blame them. It was a weird time. The Bush administration was shutting down stem cell research, and California and this group of people said, no, we don't want that to happen. So it was a weird time, and I get that, but I feel that it would have been nice if some scientists had said, you're being optimistic. And unfortunately, I don't think that you could have sold this for what the real value of the 10 years of funding was, which is a better understanding of stem cell biology and how they work. And maybe, I mean, there are some cures or treatments anyway in the pipeline, so maybe it'll turn into something. But I think we get swept up in this, oh, this is going to lead to cures and not. So I'm done. I'm not doing that anymore. I'm going to try and tell things the way they are, and if that means only talking about ants running down a highway, which I can explain if anybody's interested, so be it. But I'm told there's one more slide. So I'd be happy to take your questions. Thank you very much. By the way, if anybody's tweeting this or anything else, I deny everything. I didn't mean it, and it's not my fault.
What?
Yeah, well.
What role do you think that journalism has played in people being very cynical about science reporting, and it helps them deny science because you have a story today and then 6 months it's a different story and it denies the first story, and there's a lot of misconception about what's real science and what isn't?
Yeah. You know, okay, so are you a scientist? Okay. Which is worse, yeah, right. Right. So first of all, okay, so I was a scientist, and you've asked me for a question that I should have data to answer, and I don't, right? So if I give you an answer, it'll be anecdotal and not scientific. So I apologize. I think it's a fascinating question, and I don't have a data-driven answer. I think part of it, you're right, is that there is this pressure to overblow things because you just can't say, hey, everybody, I've got this, we call it small earthquake, few injured. It doesn't get you onto the news. And so we're under a certain amount of pressure to say things are what they are. Now, that's one factor. Another factor is that sometimes scientists aren't very good at explaining their work, and sometimes journalists aren't very smart or they don't ask the right questions. And so things can get bollocksed up in the translation. What I don't understand is what's made it get worse. And in a way, and this one, Frank keeps saying they're never going to. When you hear tomorrow, Frank won't be working here at the end of the day tomorrow because he's embarrassing himself it's a pre-recorded show, so I know he's in deep trouble. So, say hello to him tonight because after tomorrow he's gone. But I'm going to do the same thing now in a live performance. I think that there's been a response to the explosion of science journalism, that the expectations have gone up as a result. And I think that the heyday of science journalism brought a lot of stories with it that were overblown. And I think now the reality of science journalism is coming. I mean, I've been doing it as honestly as I can for a long time, but I think the reality is probably some people said, well, wait, as you say, wait a minute, I thought we solved this problem. Why are we still hearing about this? So the answer is I don't know, and I'm very distressed, and I don't have an answer. And I may be working for the totally wrong news organization because I think NPR has done a very responsible job throughout the years, and I don't feel embarrassed except in a very few occasions, by what we cover. But I agree with you that there is a greater mistrust, it feels like, and a greater dissatisfaction, and I don't know why. That's my honest answer. Yeah, sure. Oh.
Hi, Joe.
You got the microphone, you get to go.
A great presentation tonight. So I work at the University of Minnesota in communications and public relations, so I'm responsible partly for shooting out press releases to folks like yourself. My question is, we only do that, as you know, mainly around a big discovery or a new paper in Science or Nature, but I've always been fascinated by the process of discovery, and I'm wondering if you think we're missing an opportunity to tell stories that aren't just when those big announcements happen.
So, again, I wish I could say I was emblematic of a change in culture of the scientific press. I don't think I am. But I do know that a good story is a good story. And I'm totally done with whether it's in this week's Nature or last week's Nature, because that matters. You know, the only people, have you ever been you've been in a newsroom, right? They have CNN and Fox News and MSNBC, and they don't even pay attention to the main networks anymore, at least not at NPR. And so they're the only ones that keep track of what everybody else is doing, because the rest of us just look at one at a time. And so we don't know that it's been everywhere, if it's been somewhere else. I mean, unless you're studying the form. So what if it was on last week or 2 weeks ago or 3 weeks ago? If it's a good story, it'll be better when I've done it. That's right? So I completely agree. But again, you have the problem of saying, yes, but it's not news. And people are dying for a news peg. And I said, we don't need a news peg. This is a great story. And honest to God, and this may be just my own ego blowing up, but I don't need a news peg. I can go into Morning Edition and I say, I got a really good story. And they'll say, great, what's it about? And I'll say, it's about 3 minutes. No, I'll say, I love that joke. I don't think they care. I think yes, I know it's not going to lead the show. I don't lead shows. I don't care about leading shows. It amuses me when I lead shows because it means they're desperate for a lead. I just think it's important to do. And yes, so if you want an example, the American Physical Society and the American Chemical Society now put out a weekly tip sheet, and they are just interesting little things. Some of them are a month old, some of them, it's whenever they get to them. And I promise you, they've never been seen before. The ant story came from the American Physical Society's tip sheet. And I thought, well, that's kind of cool. And I didn't even do it that week. I did it a couple weeks later because all right, I'm behind on the ant highway story. Who cares? So, yes, I think we missed the boat with this need for news pegs because, again, why is it science? It's published in Science. You know that whoever did the research did it 6 months earlier, a year earlier, and they're already on to something more interesting, or they've already found that it's wrong and they don't want you to talk about it. Anyway. Yeah, sure.
Yeah, so I was, as a scientist and an editor of a scientific journal, was quite struck by your spectrum from television at one end and Science and Nature at the other. Okay. Because I would argue those of us in the science business see a spectrum, and Science and Nature are indeed at one end of it, but they're at the hype end. I think it's a very good case could be made that this article about the arsenic would never have made it into a serious chemistry journal.
So
and so the news organizations love Science and Nature, and Science and Nature is perfectly willing to publish something every so often that's just controversial and exciting, and they don't care if it's right or not.
Yeah.
So this causes all kinds of problems.
Right. So let me say two things about that. First of all, I know the editor of Science and Nature, both of them pretty well. I don't know science so well anymore. I used to know that they will never articulate that point of view, which I think is a fair one. I think they do pick. Well, John Maddox maybe once with Ben Venice. Do you remember the Does that ring a bell? Okay. Anyway, it doesn't matter. He picked a paper that he knew was like, whoa, out there. But, boy, there were titanic arguments inside the magazine about whether to publish that, too, I can tell you. It was a paper that, the homeopathy, he diluted water to some ridiculous amount and then claimed to still be able to detect antibodies to something or other. It was complete nonsense. But it got past peer review. I don't know who peer reviewed it. So first of all, so I would say they don't feel that, and they also feel like they're trying to get cutting-edge papers. And yes, it's right. All the analyses say that they get more wrong things in Science and Nature than the American Chemical Society. And that goes back to my point, which is that most science isn't news. So you can take your pick, and you could say, we won't bother with any science because it's all kind of boring and incremental, or we'll take the sizzle of Science and Nature. Well, I don't think that it's quite as extreme as you do, but I'm not sitting where you're sitting in terms of their spectrum. But the point I was going to make also is that I was working for the science section of Science News, not the editorial section. And I don't think that they hype things at all. I think they're very straight as a news organization. And so I'm not even getting into the argument about whether or not science is picking papers that they're picking for publicity. I can promise you that they did not pick the discovery of a Frank Casper sigma phase in sphere-forming block copolymer melts because they were trying to titillate their audience. Forgive me. Again, I keep doing it to him, right? I have to give Frank equal time. Who's got it now? Over there, yeah.
So I'm a graduate student here, and my experience talking about what I do or hearing other people talk about what they do to the general public, especially just in an ordinary conversation, is there's immediately people get turned off, and they just sort of you see the eyes glaze over before you even start talking, and you seem like everyone has decided that they're not going to understand what you're doing, and so why bother even trying? Mm-hmm. And then what I see sort of that iterating back to then scientists who then decide, I'm not going to even try to explain this in a way that is understandable for you because you're not even going to try to, we all have bought into this idea that maybe the general public isn't going to be able to understand what it is we do in a way that has some detail. And so I was wondering if you agree with that characterization, and is there a way that we can reverse that cycle to get people maybe interested to listen from the start and having us as scientists do a better job of trying to tailor what we're talking about in a way that they can understand?
Right. So I've thought a lot about this topic, and I don't mean to perseverate on Frank and the paper, but I think that stories are interesting for a variety of different reasons. And we can go into why I covered this story about the Frank Casper sigma phase, but if I had known a priori that the research was undertaken to find a better way to prevent chewing gum from sticking to the pavement, I wouldn't have had to come up with some cockamamie reason for doing it, because that's such a great reason. And it's such an intriguing notion to me. And so I know it's not central to the science. It's not what the paper was about. But if you're trying to explain it to people who don't really know about block copolymers and aren't that interested, but they're interested in science, I think everybody's interested. I think kids prove to us that there's an intrinsic interest in science, and we just lose it because it gets made adult at some point. And I'm bringing this back to the kid level and saying, this stuff is all incredibly interesting. And you start every conversation with that instead of backing off and saying, look, I know this is boring, and you probably don't want to hear about it, but here I go. That doesn't work. And part of the thing about telling stories is you tell stories about people. And so people are interesting. People do interesting things. People come from interesting backgrounds. I mean, they grew up in Armenia and they found their way to America and now they're studying electron microscopes. It's all interesting. It's all interesting, but it's about people. And sometimes the work is so amazing, that you can get away with the intrinsic importance of it. But most of the time, you have to sort of get people to come along with you. And so that involves telling them stories about, and I think truthfully, it's easiest to tell stories about people. So the answer is, the other thing is, if your friend's eyes glaze over, get different friends. Because I think there's cool stuff. Of course, now, I don't want to go there. Okay.
I was curious, did you originally cover the autism and vaccine story in The Lancet, and how do you feel about that decision today?
I didn't, but I probably would have. It was a striking paper with an interesting finding. I probably would have had skeptics on all sides of it. I'm sure. I feel that mystifies me. I mean, why can't we put a stake through the heart of that story and kill it dead? I can't say it often enough. It's not true. 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 It's not. Look, I did do the stories about bone marrow transplant as a treatment for breast cancer, and that was something that Congress mandated that insurance companies pay for, and it turns out that was based on fraudulent information. Now, people don't remember that one, but there was no clear evidence that stem cell transplants were an effective therapy for breast cancer. It was one study that got a lot of attention, and that one went away, I think. I don't know. I haven't looked, but you don't keep hearing people saying, go get a stem cell transplant if you have breast cancer. It may be relevant in some place. I'm not trying to make the medical decision. I'm trying to say a lot of stories that are wrong go away. Peter Duesberg printed papers saying AIDS isn't caused by HIV. He was a molecular biologist at Berkeley, and he was raising important questions about what wasn't known about how HIV caused AIDS at that point, and they had to be answered, and they were, and people don't talk about that. Unfortunately, a lot of people in South Africa died because he convinced them that he was right. But the point is, a lot of these stories die because they're wrong, and this one won't. And I don't get it. But I'm not going to say I have, 20/20 vision on these things. I'm just as capable of making a mistake. And I didn't put the example up, but there was a paper that said that there was a genome-wide association study that found particular gene loci that were associated with longevity. And then the researchers had to admit that they were using an Affymetrix chip that had overexpressed this one particular loci, and it all went away. But how was I going to know that? And it went away, and you're not hearing about it anymore. So I don't know is the answer. Anybody else want to know what I don't know?
We're going to give Joel... We'll give Joel a break now. Let's thank him for his interesting presentation. He's agreed to stay around for a little while within limits to answer questions informally, but I want to thank him on behalf of the College of Science and Engineering and give him this token of appreciation. Thank you very much.
Thank you.